So for those of you that don't know me, my name is Dennis Bowman. I have worked for University of Illinois Extension for over 43 years now, in various capacities, as a county extension advisor, as a regional agronomist, and now as the specialist for digital agriculture. And so Extension is my boss, but I also have appointments with crop sciences and the National Center for Supercomputing Applications, where the Center for Digital Ag is housed. And one of the cool things we do have at the University of Illinois is the Center for Digital Agriculture, and it is a place where a safe space for engineers and agronomists and economists all to get together and participate in grants, and get to know each other, build relationships, and compete for more grants, and they're very successful at doing that. And most of those grants are coming, a lot of them are coming from the USDA. And USDA grants all required that there be a significant portion of the grant that is dedicated to outreach. And so when they're looking, those guys are looking for somebody for their grant team that knows technology and knows agriculture and Illinois people, then they often call me and ask me if I'll be a part of their grant. And so one of our biggest grants, and one of the things that really got things started at the Center for Digital Ag, is the AI Farms, the Artificial Intelligence for Agriculture grant. It was one of the first ones in the nation to get funded. And lots of cool things are coming out of those there. And one of those is autonomous farming. And we're not looking at the kind of autonomous farming that Deere is looking at. We're tending to look smaller, things that are scalable for a variety of growers. One of our big partners on a lot of our projects is Tuskegee University. And so we're working with them to make sure some of our technology is applicable to smaller and minority farmers in the South, and any place they might be. So we're looking at things that are cheap and scalable. And one of the projects that's come out of there is this cover crop seeding robot. In the Agricultural and Bioengineering Department at the University of Illinois, there is a professor by the name of Girish Chowdhury, who is a robotics person. And he has a lot of grad students working in his lab on robotics kinds of issues for agriculture. And one of the first robots that came out of his lab was this small robot, about half the size of this one, that is surrounded with cameras. And the computers and the recording equipment in the robot can take imagery and collect data from corn plots as it goes through the field, as it moves through the plots. And the big usage for this is for plant breeders. When you're trying to find the next best corn hybrid in the world, or trying to breed up new traits in corn, there's a lot of field work and a lot of plots that go out, thousands of plots that have to be evaluated. And normally that involves a team of grad students with clipboards and measuring sticks, spending all summer going up and down the plant rows, taking measurements. The phenotyping robot can go up and down the rows and collect that data automatically and put it already in a data format. Doesn't have to be transcribed, and analysis can start almost instantly looking at that through that information. And so that robot has been very successful and has been sold to a lot of the big plant breeding companies to augment their research and development. The second robot that was coming out of the lab was looking at a weeding robot, as they thought that might be the next best use for the technology. But in the process of discussing that and meeting with farmers, one of the things they realized there was a problem, or a perceived problem, with cover crops, and a challenge of getting cover crops seeded earlier. And they thought that this could be a technology that could build off of what they did with the phenotyping imaging robot and build a cover crop robot. So this is model 3 of the cover crop robot, but it is only number 7 in the series, so it's still pretty new. This one just came off the production line this spring. A lot of the parts are custom built and 3D printed. It may look like this little seed spout on the back there is a good handle for lifting it up, but it's 3D printed and brittle as heck. And if you try to grab onto that, it'll snap off in your hand. And then I've had to hot glue a couple of those back on to keep going. So it can be a challenge. So one of the things, the very first version of this robot had a big GPS mushroom antenna sitting on top of it, and they realized that was catching on things, and so they went with a smaller patch GPS antenna. The phenotyping robot has a LiDAR sensor on the front of it to image in front of the robot to help it navigate through the rows. And with the goal of building something cheap, LiDAR is not cheap. And so they took what they learned from the LiDAR and transmitted that to just regular cheap vision cameras. So this has 3 little cheap cameras on the front of it that look down the corn row and can see where the rows are and pick the path that'll lead it down through the field. One of the big advantages of this one over last year's version of the robot is this one now has a cow catcher on the front of it to help push its way through the field. And so that'll help it navigate some downstalks and some small weeds as it's running through the field. So the big advantage, both of the robots are being commercialized by a company called EarthSense that is in the research park over at the University of Illinois. They grew out of their first incubator and are now in the bigger office space as they're trying to make more of these and do more with this. EarthSense was also one of the partners in the iCover grant. If any of you've heard of iCover, a few of you might have heard of iCover, and this is a subsidized cover crop seeding using new technology, and you might hear more about it with some of your local NRCS offices and stuff. But originally we're looking at trying to subsidize the production of a bunch of these robots for seeding cover crops and corn, and using drone seeders to seed cover crops early in soybeans. So the big advantage of this is that we can get out in the field earlier. What is our number one cover crop species in Illinois?
Cereal rye.
Cereal rye. Why?
Because it grows in the most climates.
It grows almost anywhere. It'll grow almost any time. If you put a bag of it out here, spread a bag of it out here on this patio, it would probably sprout up just fine in the cracks.
Jim brought up another reason.
Yeah?
It controls water down.
It controls water down. And winter annuals in general, just by suppression, if you get enough of it out there. But it grows in almost any condition. You can plant it after harvest up until mid-November and probably still get a stand with cereal rye. How many of you like to plant cereal rye in front of corn?
Not good.
Not good. It can be a challenge. Emerson and I had a problem with that a few years ago with one of our early cover crop plots that didn't get terminated on time. And we tried adding extra nitrogen, and it didn't really make up the difference, and about a 60 bushel yield loss in that plot. But there are a lot of other cover crop species out there that have other agronomic traits that we might want to take advantage of, and they are not as aggressive. One of the early cover crop trials I was part of was a 4-year trial utilizing about 8 different species of cover crops in a corn-soybean rotation. We used several different combinations, and the only one that worked year after year was cereal rye. Occasionally we could get another species that might work, or we'd get a second flush of crown vetch the year afterwards, but it was the only one that worked year in, year out. And we were seeding in mid-September, but you realize any cover crop seed that gets spread out, you can't really consider it planted until it gets a rain on it, unless you've got drilled soybeans that are got soil moisture contact. Otherwise, if you're just spreading it out there until it gets moisture, it's not really planted. So the idea of getting cover crop seed out earlier taking the possibility of using some other species, getting more growth, getting it established earlier. How does anybody graze cover crops? So getting additional fall growth and getting a little more growth going into the winter is probably something that you'd like to do. So this was our first year at a site at the University of Research Farm called the Farm of the Future site, where we're testing a lot of the stuff that's coming out of the AI farms and the Center for Digital Ag. And this block over here was seeded, drilled after harvest on November 3rd. And then starting at this alleyway right here and then moving across, they were seeding, they started seeding and continued for several weeks with cereal rye. They did put in a batch of spring oats there, and so this is a drone flight from the following spring, and the spring oats did what they were supposed to. They died. So there's a nice big gap, bare gap there that shows where the spring oats had been. But you can see the growth and the amount of green growth in those. You can see it over here kind of with the thermal really shows up pretty well, because with that foliage and the actively growing cover crops, it's keeping everything cooler, and that shows up in the thermal camera off the drone. Oh, there it is, thermal. NDVI. All right. So the following spring, after this seeding, this is what things looked like. On May 3rd, this was the robot seeded crop, and this was the November drilled crop. And then just about a week later, the rye was starting to head, and we still could see the stalks in the drilled plots. So we had a good stand, but it just didn't have the growth to it and the biomass that was where the robot seeded cover crop was. There had been talk earlier about Nathan Johanning's work, and so these are a couple of some information from his project, and where he's looking at planting date. We don't have any, he hasn't had any robotic seeding or ultra early planting dates in his study, but what a lot of his research does show the advantage for earlier planting. So we've got cereal rye with early, mid, and late planting dates at 24 inches of the rye and at maturity of the rye. And you can generally see with these September seeding versus October and November, you've got more biomass at the lower seeding rates. With cereal rye, when you get to the higher seeding rates, then the mid seems to do better. But the early seeding with the lower seeding rates does really well. And so that's one of the things we've seen with the cover crop robot seeder is we can get by with pretty low seeding rates. So we're looking at somewhere between 35 and 40 pounds of cereal rye seed that we've been using to test out this system. So again, it's still fairly new. Last year, our Farm of the Future field was in soybeans, so we weren't able to use the robots on it. It was all seeded by drone last year rather than with robots. So, all right, we've got, this is the also cereal rye. Let's jump on to the, what's that?
Previous one was 2024.
Okay, 2024, and that one was 2023. Just jumping to the clovers, again, you can see the advantage to biomass with the earlier seeding dates. That shows up pretty well. So as we're looking at trying to get stuff out there, get it established earlier, take advantage of any rains that might be out there, this is an option to do that. But this is still a test system. Again, this is only number 7 in the series. It uses a simple spinning spreader system. It's got a hopper that'll hold about 90 pounds of seed, and so at about a 30-pound seeding rate, we can get 2.5 to 3 acres of seeded with this robot per load.
What do you say, 3 acres?
Yeah, 2.5 to 3. So,
Does it have to go every row or not?
what's that?
Does it have to go in every row?
No, it'll seed 3 rows at a time really well. I find seeds in the outside rows beyond that as well. So it'll give pretty good coverage to 3 rows, and you'll get a little bit out a little farther, but that helps even things out. So we're looking at every 3rd row to run through the field.
And on corn density and growth and so on, or leaf
What's that?
material and density of corn, and are there barriers?
Well, it's 18 inches wide roughly, so it's gonna.
About spreading the seed out.
Oh.
It's hitting leaves and stuff.
So we're low enough that it really it bounces through there. It shoots out there. I mean, you can adjust the speed of the spinner to do that.
Any of these being used commercially?
We're seeding because of the iCover project. We're doing a lot of testing right now. So we're going to start probably Friday. There's a farmer that we're working with near in Coles County, and he's going to plant about 30 acres of cover crops Friday or early next week. And so the EarthSense team, he's going to borrow this robot to go do it himself, but he was talking with the EarthSense team, and so they're going to send their whole crew down there to try to do it all in one swoop, and give them a chance to test their equipment before they get started next week, because we're planning to seed the Farm of the Future site next week. And at the Farm of the Future site, one of the things that we did is we just put in a tile, and some of the U of I research farm is notoriously untiled and wet. And so this field has just got new tile put into it, and it's on sets of, there's 9 different individual tile that can be monitored separately. So we've got 9 plots that are going to be, we're going to be able to look at water quality on, and we're setting it up to do that, and we'll be also doing grazing. So we'll be doing cover crop with grazing and cover crop without grazing and with no cover crop across the trial. And so we'll be seeding it next week. Now the bad thing is, like we were talking about, the issues with soil health. The autonomy is not quite there yet. It will do a pretty good job of driving itself down the corn row. But if it runs into a big gap, it may try to move over a row. Or if there is a major mess of down corn or weeds, it may get hung up. But right now, the autonomy is pretty much to the point where they can fairly confidently do a pitch and catch with somebody at both ends of the field. Because they don't have the autonomy set up yet to turn it around at the other end and bring it back. The other challenge is it needs space to turn around. So we need a gap between the field rows and the headland to get this robot to turn around. Or we need no headlands to where the rows just open out on the open. So it needs space to do that.
How long does it take to do 30 acres?
So a team of 4 of them can do 40 acres in about 4 hours. So okay, 4 of them operating together can do about 40 acres in about 3 to 4 hours, and that's about how long the batteries last as well.
Battery replaceable, or you got to recharge it?
It's rechargeable. So if you would want to have probably a rack of batteries, unfortunately these are not like the drone batteries that recharge fast. These are old-fashioned lithium polymer batteries that can take hours to recharge. So
Any issues with windmills?
So this is the batteries. So windmills are going to be, you're going to have some kind of a monitoring system to adjust for those so that they'll go around, stay in the rows. So you'd probably need, this technology is not near as mature as the drone systems. With the drone system, I can just set up the field boundary. It figures out the route. I set the swath, and if there's a windmill, I just put a star on the map for an obstacle, and it goes around it. This is a lot more hands-on at this point. But this, the robotic technology is something that is happening. And this little company that's grown out of the University of Illinois and at the research park is one of the players in there. There's a lot of interesting robotic stuff coming out of Europe. One of the other projects I'm involved in is a weeding robot or some type of a AI-enhanced weeding system for the horseradish producers. They saw the John Deere See and Spray and said, "Can we do something like that in horseradish?" John Deere case, nobody is going to spend the money to develop a vision system that identifies horseradish. And so we're using that as a test case to develop a specialty crop, smart weed control system, and using AI to do that. So this is one of the technologies that's out there that we're working with. So we're going to learn a lot more this season. I'm anxious to see how things go and what we get out there, and the measurements we get. For those of you that are interested in cover crop, I'd suggest that you check out the U of I Farm Doc cover crop decision tool. So the ag economists at FarmDoc and the agronomists and the computer folks have put together a cover crop tool that you can put in your location and your planting date and your species, and it will estimate your growth and your biomass through the season. So at any point, it should be able to help you estimate how much biomass you have out there, assisting with making termination decisions and the like. And so this year we'll be feeding some of this ultra early seeded cover crop data into that model to help ground truth it. Okay, I am over my original time, but I think about on time. Okay. Questions? Yes.
When we talked earlier, you mentioned these are becoming more affordable.
Right. So our goal is to make it cost the same or less than any other seeding method that's available. And so what we don't think farmers would be buying these themselves, but a company would buy a bunch of these and put them on a trailer with the battery racks and chargers, and contract out to come do your cover crops for you.
I don't think I totally caught this, but does the University of Illinois have the IP on that?
I think it's going through the EarthSense company, a startup company.
This has got AI just for the computer vision?
Yes. So it has a computer vision system. But it's all scaled down to be cheap. It's a Raspberry Pi computer that has been tricked out to do this vision system to feed that, take that information from the cameras and build that little digital map of what's in front of the robot and the path that it needs to get through there. It can also do waypoint navigation, but that doesn't really work for cover crops unless it was an open area. So it has a bigger brother that's kind of a lawnmower sized one that would hold several hundred pounds of seed. But I have not seen it in action yet.
What about dates of planting?
So we're going to start next week with our big planting.
So this time of year.
This time of year. So we'd like to get it done by Labor Day.
Is there any possibility that that's just too early?
It is.
Okay.
It's possible. But, you know, we've seen people that have been doing cover crops, you know, trying to do cover crops at the last chance before they can't get through the field anymore with high clearance equipment. I was at one of the early cover crop experiments that I got tagged onto was Brown's in Decatur, just outside Decatur. And they had, Hagee had brought in a high boy, one of their high boys that had been converted into a cover crop seeder. And each row, they had a different method of seeding the cover crop with drops and spreaders and little tines that would rough up the soil. And they seeded their cover crops that year the last week of August, and we had a hurricane rain event that came in that weekend afterwards, and they had just amazing growth. But some of it, by the time the crop was harvested, some of it had got kind of shaded out as well. So we'll see. Need more experience.
I had a case in Wisconsin. The farmer seeded too early and he had to spray Roundup on his soybeans to kill the cover crop so he could harvest the beans.
All right. Well, thank you all very much. Thanks, Soybean Association, for inviting me out.